morning, children. Welcome to online science class. Today in this session we are going to learn about periodic classification of elements. Periodic classification of elements, unit 8 in 10th. Unit 8 in 10th. First, introduction. Rapid development in chemistry. Rapid development in chemistry in all the spheres of scientific activities. All the spheres of scientific activities in 19th centuries. In 19th centuries. For example, in 1860, 60 elements, only 60 elements were discovered. Only 60 elements were discovered. In that, all the elements had similar properties. In that, all the elements had similar properties. Okay. Then next, after that, the several new elements were discovered. After that, several new elements were discovered. Here, these elements have different properties. These elements have different properties. So, we have a number of elements were discovered. We have number of elements were discovered, but we can't remember the properties of all these elements individually. We have number of elements discovered. We have number of elements discovered, but we can't remember all the properties of elements. All the properties of elements individually. So the elements with same properties. Elements with same properties are arranged in same group. The elements with the same properties are arranged in same group. Next, modern periodic law. Next, modern periodic law. In 1912, a British scientist. In 1912, a British scientist Henry Moseley. A British scientist Henry Moseley discovered the new property of an element. Henry Moseley discovered the new property of an element is called atomic number. New property of an element is called atomic number, which is the basis for the periodic arrangement of elements. Which is the basis for the periodic arrangement of elements. Periodic arrangement of elements. Here, what is atomic number? What is atomic number? Atomic number of an element. Atomic number of an element is equal to the number of protons. Number of protons or number of electrons. Number of protons or number of electrons present in a neutral atom of an element. Present in a neutral atom of an element. So, the modern periodic law states that. So, the modern periodic law states that the physical and chemical properties. The physical and chemical properties of an element. The physical and chemical properties of an element are the periodic functions of their atomic number. Periodic functions of their atomic numbers. So, the modern periodic law. Modern periodic law states that the physical and chemical properties of an element are the periodic functions of their atomic number. Periodic functions of their atomic number. Okay. Next, modern periodic table. Next, modern periodic table. modern periodic table is the tabular arrangement of elements. Tabular arrangement of elements in periods and groups. In periods and groups with regular repetition of properties of the element. Regular repetition properties of the element. Regular repetition of the properties of the elements. That means the properties of elements. That means the properties of elements repeated after certain interval of time. Repeated after certain interval. Repeated after certain interval. And the table formed by the elements were arranged in the increasing order of their atomic number. The elements were arranged in the increasing order of their atomic number. Okay. Next, features of periods. Before going to that, what is period? The horizontal rows from left to right. The horizontal rows from left to right are called periods. Okay. What is period? Horizontal rows. Already I told you the elements are arranged in rows and columns in the periodic table. Okay, the elements are arranged in the rows and columns in periodic table. Here, the period means the horizontal rows from left to right. From left to right are called periods. There are 7 periods in the periodic table. There are 7 periods. How many periods in the periodic table? There are 7 periods in the periodic table. 1, 2, 3, 4, 5, 6, 7. So 7 periods in the periodic table. Okay. Here first period. Let us see here. Here this is the first period. Here one element, here one element. So atomic number 1, 2 and 2. Atomic number 1 and 2. It contains 2 elements. Here one element, here one element. That means hydrogen and helium. Hydrogen and helium. So it contains 2 elements. So this is a shortest period in the periodic table. This is the shortest period in periodic table. Okay. And the next second period. The atomic number from 3 to 10. The atomic number 3 to 10. Here it contains 8 elements. It contains 8 elements. This is here 1, 2, 3, 4, 5, 6, 7, 8. So it contains 8 elements. So this is the short period. This is the short period. From elements from lithium to neon. Lithium to neon. Okay. Next, third period. Here atomic number 11 to 18. 11 to 18. It contains 8 elements. It also contains 8 elements. Here 1, 2, 3, 4, 5, 6, 7, 8 elements. So third period also contains 8 elements. So this is also a short period. Okay. From the element sodium to argon. Sodium to argon. Okay. And then next, fourth period. Next, fourth period from atomic number 19 to 36. 19 to 36. Atomic number 19 to 36. It contains 18 elements. It contains 18 elements. Okay. Here contains 18 elements. Include that 8 normal elements, 10 transition elements. Here, this is the transition element. This is the transition elements. Here, normal elements. Here, 2 elements. Here, 2 normal elements. Here, 6 normal elements. Here, 6 normal elements. 1, 2, 3, 4, 5, 6. Okay. So, totally 8 normal elements. 8 normal elements. 10 transition elements. 10 transition elements. This is the long period. This is the long period. Okay. Next, fifth period from element rubidium to xenon. Rubidium to xenon. It also contains 18 elements. It also contains 18 elements. In that, 8 normal elements. Like fourth period, here 2 normal elements and here 6 normal elements. Totally 8 normal elements and 10 transition elements. 10 transition elements. Okay. So totally contains 18 elements. Totally contains 18 elements. So this period also long period. This period also a long period. Okay. And then next, sixth period. Next, sixth period. Element from cesium to radon. Cesium to radon. Atomic number 55 to 86. 55 to 86. Okay. Next, sixth period. Next, sixth period from atomic number 55 to 86. 55 to 86. Okay. In sixth period, atomic number 55 to 86. 55 to 86. From element cesium to radon. Cesium to radon. From element cesium to radon. Okay. It contains 32 elements. Sixth period contains 32 elements. In that, 8 normal elements. 8 normal elements. Here 2 normal elements. Here 6 normal elements. Here 6 normal elements. Totally 8 normal elements and 10 transition elements. 10 transition elements. Already told you the transition elements present in the middle portion to the left portion and the right portion. Right portion and the left portion. Okay. 14 inner transition elements and 14 inner transition elements. Okay. 8 normal elements. 1, 2. Here 2 normal elements. Here 6 normal elements. Here 6 normal elements. Totally 8 normal elements and 10 transition elements. 10 transition elements and 14 inner transition elements. Here 14 inner transition elements. These inner transition elements present in the form of part of group 3. Part of group 3. Okay. This is the sixth period and seventh period. Next, seventh period. Like sixth period. Like sixth period. Seventh period also accommodates 32 elements. Seventh period also accommodates 32 elements. Here also 8 normal elements, 10 transition elements, 14 inner transition elements. But recently 4 elements present in the group by IUPAC. By IUPAC. IUPAC means International Union of Pure and Applied Chemistry. Pure and Applied Chemistry. Applied Chemistry. So this is the 7th period. Okay. So this is the futures of periods. This is the futures of periods. Next, futures of groups. We will learn about futures of group in next class. Okay. In next class. Thank you.